Hi guys, Mrs. Young here. This is day 2 of our 3D unit where we are talking about cross sections and revolving 2D shapes around to create 3D shapes. The pages that you printed for notes and homework, I'm not going to use till the end of the video, so you can put those to the side. You want to have out your spiral, and we're going to actually go to a website. We went to shoto.org on Monday's lesson, Interactive 8 Activities. We were in the cross-section activity today. We're going to look at the 3D transmographer. You're going to be going from the video to this website. So you want to have both tabs open on your computer so you can go back and forth, and we'll be writing stuff down in the spiral as we go. So when you get to that page, I'll show you this in a second. We're going to go to new polygon, 4 vertices, we click go, and then we're going to type in these vertices. Once we type them in, we click graph, and then we're going to sketch a graph of this in our spiral. So I'm going to refer back to this page. So we're going to come back to this in a minute. Maybe you want to jot those numbers down, but I'll refer back to this as I'm going to this transmographer website. So we're going to switch the page that I'm sharing with you. Let's see if I can do this. And jump over to that 3D transmographer. It's a really cool website. I'm going to encourage you to take some time to jump around or play around with it as you can. Sorry. So we're on shoto.org, Interactivate Activities. We were on this the other day. Maybe you bookmarked it, hopefully. And the other day we were using this cross-section flyer down here. So today we're going to use the 3D transmographer. 3D transmographer. So when you get to that website, over here on the right side, it says new polygon, 4 vertices. We're going to click go. And then we're going to type in those vertices that I mentioned from before. So we're going to have 0, 6. I think it was 4, 6, 4, 0, 0, and then 0, 0. And then once you get all of your vertices typed in, you're going to go ahead and click graph, and you'll see the graph of that shape created by those vertices. So this would be a great spot to pause your video, go to this 3D transmographer website and type in those vertices and then click graph. Okay, so I'm gonna really encourage you to go ahead and pause the video and go to that website and type those in. Pause it and do that. Okay, so next, this website, this 3D transmographer, is really about transformations. We could take this rectangle and we could translate it, right? We could shift it right, left, up, down, whatever. You'll notice over here, you could rotate it. You could rotate it 90 degrees, 180, 270, 60 degrees, whatever. So you can rotate it. We're not going to use either of those. You could reflect it over the X or Y axis. We're not going to do that. We're going to revolve it. So you're going to revolve it. You can pick how slow or fast it actually spins or revolves. I'm going to go slow, but you can pick whatever you want. And we're going to practice revolving it around a few different lines. So I want to revolve it around the x-axis. So I want to take this rectangle and revolve it around the x-axis. I know the x-axis is y equals 0. Notice here when it says y equals, it says 0x plus 0. This first 0 is your slope, and then this last one is your y-intercept. So it's the same as saying 0x plus 0 or y equals 0. We're just going to leave it as zeros. And then once you have that keyed in, I want you to go ahead and click revolve. So again, you might want to pause this video for a second, jump over to your website and try to revolve it, or you could just watch me if you'd rather. And you can see when you revolve it, it creates a cylinder. Just like our other website, you can left click on your mouse and drag it around and see it from all different angles or perspectives. That is a cylinder, right? You can reset the view to go back to where you started. It's a solid view, but we could make it a wireframe view. I'm going to spin it around. Looks like a Ferris wheel kind of, right? Or a little hamster wheel, right? But I prefer the solid view. That's just me. Reset it back. So when we revolve this, over the x-axis, or y equals 0, we created a cylinder. What do we know about this cylinder? We know this cylinder has a radius. Right here I can count 1, 2, 3, 4, 5, 6 is my radius, and then my height is 4. So it's a 6 by 4 cylinder, which I could then calculate the volume of. And that's something that we're going to be doing in this unit, taking 2D shapes, revolving to create 3D shapes, and then finding the volume of these shapes. So I'm going to go back to my smart file that I was on. So again, we typed in this, we graphed it, and then we revolved it around the x-axis. What I would like you guys to do is now sketch that on some graph paper and find the volume. Then I'm going to ask you to go back to that same screen we were on, and this time type in revolving it around y equals 3, sketch it and find the volume. Revolve it around x equals 0, which is the y-axis, sketch and find the volume. And then revolve it around x equals 2, again, sketch and find the volume. So you're going to be doing 4 separate problems here. I'm going to start the first one with you. So we know what that shape looked like on the other screen. So I'm going to go to my graph paper, and I'm going to go ahead and sketch this cylinder. Again, we know that we had a rectangle that was, I think it was like 4 here. Maybe I would choose a different color, 4 here. And then it went up 2, 4, 6 here, right? So that was the rectangle that we started with. This was our, remember, this was our radius of our cylinder, which was 6. And then this was our height, which was 4. And I'm going to try to draw my 3D shape. So 1, 2, 3, 4, 5, 6 down here. See if I can draw my cylinder. Again, you guys are way more artistic than I am, right? So I expect you guys probably doing a much better job than me to create this cylinder shape. So you're going to have to take a 2D shape, revolve it around something to create a 3D shape, and then now I want you to tell me what is the volume of this shape. So I know that this is a cylinder. I know for a cylinder, the formula is volume equals pi times the radius squared times the height. So pi times 6 squared times 4. 6 squared is 36. 36 times 4 is 144, so it's 144 pi. For all of these, obviously on a coordinate graph, we don't have specific units, but we can just say our units are cubed. So that's the first one for you. And let me go ahead and help you start the second piece here. So you're going to go back to that same graph, but this time I want you to revolve around y equals 3. Then I want you to do x is 0, then x is 2. So when you're done on that other page, you're going to have 4 shapes. You can graph them separately, and you should have a sketch of each of them with their volumes calculated. So let's go back to that program, and let's try to sketch, or at least look at the shape revolved around y equals 3. So I have to change the page that I'm sharing with you. This is a little tricky. Where am I? There we go. So now, instead of revolving, this is where you have to be careful. This is y equals 0, x plus 0. And I said I wanted to revolve over y equals 3. That means, again, we still have a 0 slope. There is no x value. So you want to put the 3 way over here. And if you put the 3 here, it's going to be a slanty line. I want not a line at an angle. So once I have that, I'm going to go ahead and click revolve and see what happens. So again, there's my line y equals 3. It's a horizontal line, which I expected. It is still creating a cylinder, but you'll notice that this time your cylinder has a height of 4 still, but the radius this time is 3. So different radius because I revolved around something different. Again, you can always spin around and look at it, make it a wireframe view if you need to. So what you need to do next is sketch this, find the volume, and then again, come back to this program and do it again for x equals 0 and then x equals 2. So maybe pause this here, go to your program and practice each of those. So you should wind up with 4 shapes total with 4 volumes calculated for each of them. So this is where I would expect you to pause the video and take a couple minutes to come up with those shapes. So pause it and work. Okay, so this was the cylinder that we had originally done together, and we had 144 pi for the volume. Then for the other three that you came up with, I just did little sketches down here to show you. The one was a cylinder with a radius of 3 and height of 4. That's where we just left off. We were looking at that. That had a volume of 36 pi. Then when you revolved it around x equals 0, here you had a radius of 4 and a height of 6, so you should have 96 pi. And then the last one, when you revolved it around x equals 2, it kind of revolved on top of itself. It was a much skinnier cylinder. And there we had a volume of 24 pi. All of these should be my units cubed, okay? Units cubed. Let's go ahead and, again, that's just kind of showing you how to take your 2D shapes, revolve them to get 3D shapes, kind of using the program to help you out. This unit is all about having a strong visual sense of what is happening. So the better, visual learner you are, the better it'll help you in this unit. So I'm going to go back to that program really quick, and we're going to just look at a different shape. And I'm not even going to have you graph any of this or worry about this, but I just wanted to show you a few things. Let's say that instead of doing a quadrilateral, let's go new polygon, and we can go with a completely new shape. So maybe I'm going to try a polygon that has 3 sides, which we know is a triangle. I'm just going to let it default to the values that they came up with. And here's my triangle. And as an example, let's say that I revolve this around, let's go back to, I'm going to try y equals 0, right? So I'm going to revolve it around y equals 0. Click revolve. What do we think is going to happen? Well, obviously, if you revolve it around the x-axis, you're going to create a cone. And I could even say, oh, find the volume of that cone, right? 1/3 pi r squared h. So we know how to find the volume of a cone. What if instead of revolving it around y equals 0, what if we revolved it around y equals 5? Notice that I'm not entering anything in front of the x value. That would give you a slope, and that would be a slanted line. I'm still looking for my horizontal lines here. So I'm revolving it around y equals 5. And this time, the shape that you create, this is actually called a truncated cone, right? It's like a cone with the chop topped off. And they scooped a cone out from inside of it. So technically, that's a truncated cone with, maybe you can barely see it there, a cone scooped out of the middle. Another one that we could try, maybe instead of across the y, we'll try across the x. And let's go across x equals -3. Again, I'm going to click revolve. Well, this just creates 2 identical cones stacked together at their bases, and they're both the same size, right? And you can see them from each perspective or angle, or spin it around if you need to. So you've got 2 cones, and that one I could definitely have you find the volume of. That's an easy one. Or we could find the, let's try instead, let's say x equals 6. I'll click revolve there. So you can see that you're creating a cylinder, right? That's a cylinder shape. But then you can almost see with those faint lines that you've scooped a cone out of the top and a cone out of the bottom, right? So that's a kind of a fun shape. And sure, we could find the volume of that. We could take the volume of the cylinder minus the volume of each of those cones. So you can see how this third section of the unit connects back to the second section, where we're still using some of our formulas that we've seen from before, right? So I'm going to go back to my smart file for a second here. If you want to go back and play around with that website we were just on, that 3D transmographer, here we go. This is what I was just doing. I did a triangle, 3 vertices, and I plugged in those different vertical and horizontal lines to revolve around. So if you want to pause the video and go ahead and try some of those, you can. Maybe pause it right here so you can, and I just let it default to my vertices that time. I didn't type in something specific, so I was just trying to make it quick and easy to show you. But I would also encourage you to take some time, either now or later, to just kind of play around on that website. Try different shapes and revolve them and see what it looks like, and look at them from different angles or perspectives. Okay, so maybe pause the video and play around with that for just a minute or two. Okay, so now I am to the page of notes that hopefully you printed out for me. And it just kind of talks about this whole revolving concept and how when you take a 2D shape and revolve it, you create this 3D shape. So the cross section of the door, right? But then when I revolve it, it becomes this cylinder. Why are we doing this? Why is this important? So a different way to fill space and create volume is to rotate 2D figures about an axis. This technique gets used quite a bit in higher math to determine the volume of a shape. In calculus, we find ourselves finding the area under the curve for all different kinds of shapes. And this is a great preparation for that. So you're going to see some of what I'm talking about will come back in calculus. Initially, like in Calc 1 or 2, you'll take a curve and you'll try to find the area under that curve. And then when you get to Calc 3, at least from when I was in college, this was Calc 3, they took that line and they would rotate it about the X or Y axis and create a 3D shape that you then had to find the volume of. So you'll see a lot of this more when you get into Calc 2 or 3 specifically. Calc 3 is where you're going to take the shapes and revolve them to get those 3D shapes, and then you'll have to find the volume of them. So again, I know this a few years down the road, but I just want you to know this is kind of important stuff. There's a now you try some down here at the bottom. They want you to look at these 2D shapes. Imagine that you're rotating them about that line of axis, that axis line, spin it around that and create a 3D shape. So go ahead and pause your video here and sketch what you think these 3D shapes would look like. And then I'll come back and share with you what mine look like too. So again, pause it and just try to sketch those 3 shapes. Okay, so the one on the left, very similar to what we did earlier. When you take that rectangle and revolve it, you create a cylinder. The one in the middle is a little bit trickier. I for sure had a hard time with it. When you rotate it or revolve it, you create a cylinder with a small cylinder cut out of the top and a small cylinder cut out of the bottom. And then the third one, the one on the right, when I revolve that shape, I create 2 cones stacked together at their bases. The one on the top, that cone on top, is bigger than the cone on the bottom, right? Yes, so then there's 2 cones stacked together. I was just kind of playing around with that 3D transmographer website. And what I did is I tried to come up with vertices of the second one so I could show that to you what it really looks like, because I know that my picture, I felt like my picture was kind of hideous. So I just wanted to show you what it looked like for me. So I'm going to go back to that fun website I was on, my 3D transmographer, and it took me a while. I came up with all those vertices to create the shape that looked just like number 2 there, and now you try these. And I wanted to revolve this around the y-axis, which is x equals 0. So I'm going to go ahead and click revolve, and you can watch this. And you can see it's like a skinny cylinder, right? Or a flat cylinder with a little cylinder cut out of the top and a small cylinder cut out of the bottom, like a little ridge or cylinder cut out of the top and the bottom. Kind of cool, right? So again, I took the time just to show that to you for fun. Your homework tonight, maybe that's what I should show you. I'm going to go to a different screen. We use this first page for our notes. So then pages 2 and 3 are going to be your homework. And it's a lot of sketching. And I know some of you are very artistic and some of you not so much. So do the best that you can. Best bet would be to print out these pages and sketch right on these pages. Make sure that you are doing the sketch and, like here it says, describe it to me. Like I did in those last 3, make sure you describe to me what it looks like and sketch it. Here, number 2, you're working backwards. They give you the 3D shape. They want to know what the 2D shape beforehand, before the revolving, what did it look like before? And then down here again, you're trying to draw your 3D shapes, sorry, your 2D shapes to give you the 3D shape. And then number 4, if you revolve these, what kind of shapes would you get? So again, a lot of sketching, but then don't forget about describing as well. So that is your homework for tomorrow. If you have any questions, please reach out to me. If not, I will talk to you later. Thanks, guys. Bye.